Good day everyone, and welcome to where we are putting together solutions in additional mathematics in the topic of Introductory Calculus and Kinematics. This video focuses on 5 years past paper solutions from May 2017 until May 2022. Feel free to like the video and add any comments down below so we can help create other videos for you in whichever areas that you are struggling with. Don't forget to look at the description down below where we have outlined the order that you should follow to cover the entire CSEC Additional Mathematics syllabus for you to get a better grasp of the subject area. Let's now look at the major subsections in additional mathematics, and this video looks at section 3, Introductory Calculus. This can be subdivided into differentiation, integration, and kinematics. Differentiation can be subdivided into the gradient of a curve and the derivative as a limit, the first and second derivatives, which can be represented as f bar x, dy dx, and f double bar x, derivative of x to the n, sine ax, cos ax, c fx, where c is a constant, the derivative of f of x plus or minus g of x, the chain, product, and quotient rules, the equations of tangents and normals, and the nature of stationary points, where we look at the sign change or second derivative. If we look at the subdivision, integration, that can be broken down into indefinite integrals of f of x, c f of x, where c is a constant, and f of x plus or minus g of x, all with respect to x. Integrate polynomials, such as the integral of ax plus or minus b to the power n with respect to x, where n is not equal to 1. Integrate trigonometric ratios, such as the integral of a sine px plus or minus b cos qx with respect to x. Definite integrals, such as the integral from a to b of f of x dx, which is equal to f of b minus f of a. Find the equation of a curve given the gradient function and a point, the area of a region in the first quadrant, and the volumes of revolution. Kinematics can be broken down into real-world applications, where we look at the kinematics in terms of ST and VT graphs, which are distance time and velocity time graphs, and rates of change. Also, kinematics includes S is equal to the integral of V, velocity, with respect to t, and V is equal to the integral of A, acceleration, with respect to t. As we look at the 5 years, we can see there's a discernible change. From May 2017, 18, and 19, this followed the old syllabus, in which differentiation was tested as number 5 with 14 marks, integration tested as number 6 with 14 marks as well, and kinematics as number 8, the last question on the paper, with 20 marks. However, with the new syllabus change in 2019 and no paper in 2020 because of the pandemic, from May 2021 and 2022, kinematics was integrated within the calculus questions. So we can see that differentiation from May 2021 was numbers 4a and b, and part C was kinematics, as well as integration 5a and b was integration, and 5c was kinematics. And this gave a restructuring such that number 4 was worth 15 marks, and number 5 was worth 15 marks. So in paper 2, under the topic of calculus, it was now worth 30 marks. Just as in paper 1, it has 10 multiple choice questions. May 2017, number 5a, differentiate the expression 1 plus 2x cubed times x plus 3 with respect to x, simplifying your answer. So let g of x equal to this product, and let's recall we can use the product rule, which is d dx of uv is equal to u dv dx plus v du dx. And notice we have u and v in different colors for students to easily be able to identify and follow along. So let u be equal to 1 plus 2x cubed, such that the differential of u du dx is equal to 3 times 2 times 1 plus 2x to the power 2. And v is equal to x plus 3, such that dv dx is equal to 1. So g of x is equal to 1 plus 2x cubed by x plus 3. So the differential of that g prime x is equal to u dv dx plus v du dx from the product rule. And if we substitute, it will give us 1 plus 2x cubed by what's dv dx? 1 plus x plus 3 by du dx, which is 3 by 2 by 1 plus 2x squared. And if we expand a little bit, we can have 1 plus 2x by 1 plus 2x squared as we break up the 1 plus 2x cubed, plus 6 times x plus 3 will give us 6x plus 18 by 1 plus 2x squared. So we can factorize out the quadratic, so it will give us 1 plus 2x squared by 1 plus 2x plus 6x plus 18. So that will finally give us 1 plus 2x squared by 2x plus 6x is 8x plus 1 plus 18 is 19. 8x plus 19. Part B. The point P minus 2, 0 lies on the curve y is equal to 3x cubed plus 2x squared minus 24x. So we'll bring up this curve so students can see what it looks like. It is a cubic equation, so it means it starts from negative infinity, goes up to maximum, comes down to minimum, and goes back up to positive infinity. And let us now apply the point P minus 2, 0. So this shows that there's a problem with the question, because the question states that the point P lies on the curve, and clearly we can see that it doesn't. But we'll continue solving it as is. So determine the equation of the normal to the curve at the point P. So let's theoretically solve it. Y is equal to 3x cubed plus 2x squared minus 24x. So if you want to find the gradient of the line, then we need to differentiate. So dy dx is equal to 9x squared plus 2 by 2 is 4x minus 24. And at the point P, where x is equal to minus 2, then we can substitute. So dy dx is equal to 9 by minus 2 squared plus 4 by minus 2 minus 24. Minus 2 squared is 4, 9 4 are 36. 36 minus 8 is 28. 28 minus 24 is 4. So the gradient is equal to 4. And let's recall that if we want to find the normal to the curve, then the gradient of the tangent mt times the gradient of the normal is equal to minus 1, because they will be perpendicular to each other. So 4 times mn is equal to minus 1. So the gradient of the normal, mn, is equal to minus a quarter. I'm not going to be able to represent this on this curve, as I've done in other questions in all the other videos, because of the fact that it doesn't even touch the curve. But we continue theoretically. So the gradient of the normal is equal to change in y over change in x. And we know the gradient of the normal is minus a quarter, so we can substitute. And that will be equal to y minus, and what point does it go through? Point P, where the y value is 0 and the x value is minus 2. So we'll get minus a quarter is equal to y minus 0 over x minus minus 2. So we can carry the denominator across because we're solving for y. So that will give us minus a quarter by x plus 2. And we can expand. So y is equal to minus a quarter x minus a half. And that would be the equation of the normal, assuming that the point P really lied on the curve. And to confirm that it doesn't lie, if we substituted the x value as minus 2 into the equation, it would give us plus 48. So definitely it would not give us y is equal to 0. May 2017, number 5C. Water is poured into a cylindrical container of radius 15 centimeters. The height of the water increases at a rate of 2 centimeters per second. So we can see that happening there in the general sketch. So what does that mean? As the water is being poured in there, then the height is increasing by 2 centimeters every second. As such, that means that the volume is increasing. Given that the formula for the volume of a cylinder is pi r squared h, determine the rate of increase of the volume of water in the container in terms of pi. So if we want to find the rate of the increase of volume of water, that means dV dt. So this is a rate of change question, so we can write dV dt is equal to dH dt times dV dH. And we know the volume is equal to pi r squared h, so we can differentiate that with respect to h. So dV dH is equal to pi r squared, because pi and r are constants, where r is equal to 15 centimeters. And we know dH dt, they give us the rate at which the height increases, and that is 2 centimeters per second. So if we substitute, dV dt is equal to dH dt times dV dH, which is equal to 2 times pi times r squared, where r is 15. So 15 squared is 225, 225 by 2 is 450 pi. So dV dt is equal to 450 pi centimeter cube per second. May 2017, number 6a. Show that the definite integral between the limits 0 and pi on 4 of sine x plus 4 cos x with respect to x is equal to 3 root 2 plus 2 all over 2. Let's integrate that value, and notice we've put the limits between 0 and pi on 4 in different colors so students can identify how the process is happening. So if we integrate sine x plus 4 cos x, it will give us the integral of sine x is minus cos x. Or if we go backwards, if we differentiate minus cos x, it will give us sine x. Plus, what's the integral of 4 cos x? 4 sine x. Plus c, the constant of integration. But because it's a definite integral, when we substitute the values, the constant of integral plus c will cancel. So you can either put it in or leave it out because it will disappear at the end. Now we can substitute for the values. So those limits will give us minus cos pi on 4 plus 4 sine pi on 4, the upper limit, minus cos 0 plus 4 sine 0. And we know cos pi on 4 is root 2 on 2. So that will give us minus root 2 on 2 plus sine pi on 4 is the same as cos pi on 4 because it's 45 degrees each. So that will give us plus 4 root 2 on 2 minus cos 0. And cos 0 is 1. So minus is plus 1 plus 4 sine 0, and sine 0 is 0. So we can now use a common denominator of 2. So it will give us minus root 2 plus 4 root 2 plus 2 all over 2. And 4 root 2 minus root 2 is 3 root 2 plus 2 all over 2. As such, we have proven what was required. So we can either bring up a small square to represent such that we've completed the proof, or we can write QED, quod erat demonstrum, a Latin phrase to represent the same thing. Part B. Determine the equation of a curve whose gradient function dy dx is equal to x plus 2, and which passes through the point P, 2, 3. So dy dx is equal to x plus 2, and from there we can integrate to find y. So if we integrate with respect to x on both sides, it will give us y on the left-hand side is equal to, what's the integral of x? X squared on 2, or half x squared, plus what's the integral of 2 with respect to x? 2x, plus c, the constant of integration, because this is an indefinite integral in comparison to part A. And if we look at that equation that we've written, we have three unknowns, y, x, and c. And we can solve for c because at the point P, we know the values for x and y are 2 and 3. So let's substitute. 3 is equal to half by 2 squared plus 2 by 2 plus c. So 3 is equal to 2 squared is 4, half of 4 is 2, plus 2 2s are 4, plus c. So 2 and 4 is 6. I carry the 6 across. 3 minus 6 is minus 3 is equal to c, which is the constant of integration. So the equation of the curve whose gradient function is dy dx equal to x plus 2 and passes through that point is y is equal to a half x squared plus 2x minus 3. May 2017, number 6c. Evaluate the definite integral from limits 1 to 2 of 4 minus x all squared with respect to x. So we can expand the brackets. So 4 minus x by 4 minus x will give us 16 minus 8x plus x squared. And for those who can't work it out quickly, then let's bring up a little sketch here of 4 rectangles whose length is 4 minus x, and its width is also 4 minus x. So if we subdivide it into parts, we can see for the first rectangle up on top, the length and breadth is 4, so 4 fours are 16. For the rectangle to the right on top, 4 times minus x is minus 4x. For the rectangle down below, 4 times minus x is also minus 4x. Minus x times minus x is plus x squared. So if we add up the area of these 4, we're going to get 16 minus 8x plus x squared, which is what we have up on top. And now if we integrate such with respect to x, then it's going to give us 16x minus 8x squared over 2. And we can divide the 2 into 8, that will give us 4, so minus 4x squared plus x squared over 3, or 1/3 x cubed, between the limits 1 and 2. So we can now substitute for x, with the upper limit being 2 minus the lower limit being 1. So that will give us 16 by 2 minus 4 by 2 squared plus 1/3 by 2 cubed minus 16 by 1 minus 4 by 1 squared plus 1/3 by 1 cubed. So that works out to be 16 twos are 32 minus 2 twos are 4, 4s are 16, 32 minus 16 is 16, plus 2 cubed is 8 over 3. 16 plus 8 over 3, so 16 threes are 48. 48 plus 8 is 56 over 3, minus 16 by 1 is 16, minus 4 by 1 is 4, 16 minus 4 is 12, plus 1/3. 12 plus 1/3, 12 threes are 36, and 1 is 37 over 3. So we got 56 over 3 minus 37 over 3. Of course, you could use a calculator to work this out. And that will give us 56 minus 37 is 19 over 3 square units. Part D. Calculate the volume of the solid formed when the area enclosed by the straight line y is equal to x over 2. And let's bring up that graph. And the x-axis for x equal to 0 and x equal to 6. Bring up that line. Rotate it to 2 pi or 360 degrees about the x-axis. So that will give us cone. So how do we work that out? Volume is equal to pi times the integral from a to b y squared dx. And we know y, that's a straight line, x over 2. So y is equal to the integral from 0 to 6 of x over 2 squared with respect to x. And we can work out that square, so it'll give us pi times the integral of x squared over 4 with respect to x. And the integral of x squared over 4 will be x cubed over 4 times 3, which is 12. So we can now substitute the upper and lower limits for that. So it'll give us pi times 6 cubed over 12 minus 0 cubed over 12. And of course the 0 will disappear. So 6 cubed will be 6 times 6 times 6 all over 12. 6 into 6, 1, 6 into 12, 2. 2 into 1 of the 6s is 3. 3 6s are 18. So we'll be left with 18 pi cubic units. May 2017, number 8a, and this is a kinematics question. The displacement s of a particle from a fixed point O is given by s is equal to t cubed minus 5 over 2 t squared minus 2t meters at time t seconds. Part 1. Determine the velocity of the particle at t is equal to 3.5 seconds, clearly stating the correct units. So v is equal to ds dt, or the differential of s. And we know s, that's given above, so we can substitute v is equal to d dt of t cubed minus 5 over 2 t squared minus 2t, and if we differentiate with respect to t, it will give us 3t squared minus 5 on 2 times 2t, which will give us minus 5t minus 2. And we know for this particular question, the time is 3.5 seconds. So let's substitute that. When t is equal to 3.5 seconds, v is equal to 3 by 3.5 squared minus 5 by 3.5 minus 2, which works out to be 17.25 meters per second. So that's the velocity when the time is 3.5 seconds. Part 2. If the particle is momentarily at rest, of course we could bring up a little sketch for students to follow along, where the velocity is just quadratic, 3t squared minus 5t minus 2. And for part 2, if the particle is momentarily at rest, find the time t at this position. So if it is at rest, it means that's the point where the velocity is 0. Or for this quadratic equation, where it's cutting the x-axis, the roots of the equation. So when v is equal to 0, we can substitute 0 is equal to 3t squared minus 5t minus 2. And we can solve this quadratic either using the quadratic formula or factorizing. So it's quicker for me to factorize, so it will give us 3t plus 1 by t minus 2. So either 3t plus 1 is equal to 0, so 3t is equal to minus 1. So t is equal to minus 1/3, and we can bring up that to show it on the graph. So at the time minus 1/3 seconds, the velocity is 0. And of course, we can't get negative time, so that value won't work. Or for the second bracket, t minus 2 is equal to 0. So t is equal to 2 seconds, and we can bring that up. Therefore, if the particle is momentarily at rest, it must be on the right-hand side when the time is 2 seconds. May 2017, number 8b, the second part of the kinematics question. A vehicle accelerates uniformly from rest for 75 meters, then travels for another 120 meters at its maximum speed. The vehicle later stops at a traffic light. The distance from rest to the traffic light is 240 meters, and the time for the journey is 15 seconds. Part 1. In the space below, sketch a velocity time graph to illustrate the motion of the vehicle. So let's bring up a graph with the axes, time, and velocity in meters per second. And let's put in the information. So first of all, what do we know? It starts from rest. So let's bring up a little x there to show us where that is at the origin. And then it traveled for 75 meters. So the velocity increased, and we know that distance here, s1, is 75. So it moved up to some velocity v1 there. We could bring that up in a green line. And then it remains at this maximum speed for 120 meters. So the velocity v1 remains constant. So you can draw a horizontal line showing that, and that being represented as s2. And the vehicle now comes to stop at a traffic light. So that will cover another distance, s3. So it slopes downwards until it meets the x-axis, or the velocity is 0. So we represent the distances s1, s2, and s3 with time intervals t1, t2, and t3 respectively. And we know the entire journey took 15 seconds. So part 2. Calculate the length of time the vehicle maintains constant speed. So we know 15 seconds is equal to t1 plus t2 plus t3. And we also know the total distance, 240 meters, s1 plus s2 plus s3. So 240 can also be represented as the area of a trapezium, which is a half times the perpendicular distance, v1, times the length of a parallel line, which would be t2 plus 15. So if we try to solve for that, we can carry the half across. It will give us 480 is equal to v1, t2 plus 15 v1. Now, do we know s2? The distance traveled in the middle section will be the area under that, which is a rectangle. So it will be v1 times t2, length times breadth. And if we substitute, we know the distance there, s2. That was given above, 120 meters. So 120 is equal to v1 times t2. So we can substitute into what we just wrote. So 480 is equal to 120 plus 15 v1. So we only have one unknown, so we can solve for that. So we carry the 120 across. 480 minus 120 is 360 is equal to 15 v1. So v1 is equal to 360 divided by 15, which is 24 meters per second. So we know v1 is equal to 24. So let's bring up the equation we have in green. 120 is equal to v1 by t2. And we just worked out v1. So 120 is equal to 24 times t2. So t2, the second time interval, the length of time which the vehicle maintains a constant speed would be 120 divided by 24, which is 5 seconds. Part 3, calculate the maximum velocity attained, which is v1, and we worked that out already above, which is 24 meters per second. And part 4, the last part of the question, determine the acceleration of the vehicle. The acceleration is the gradient, which is change in v over change in t. And we know the change in velocity, that is 24. We worked that out already in part 3. But do we know t1, the change in time? So we need to go work that out first. So we know s1, the distance traveled in that first triangle, that first part of the motion. s1, which is the area on our triangle, is 75, would be equal to a half length times breadth. So a half v1 t1. And we know v1 is 24. So 75 is equal to a half times 24 t1. A half of 24 is 12. and carry it across. 75 divided by 12 is 6 1/4. So the time t1 for the first interval will be 6.25. So we can now substitute. So acceleration is 24 divided by 6.25, which works out to be 3.84 meters per second squared. May 2018, number 5a. Given that y is equal to x cubed plus 2x squared minus 1, determine, part 1, the coordinates of the stationary points. So if we know y, we can find the differential dy dx, which will be d dx of x cubed plus 2x squared minus 1. And if we differentiate the right hand side, dy dx will give us 3x squared plus 4x. And for a stationary point, what do we recall? That the gradient at that point is 0. So dy dx is equal to 0, so we can substitute. 0 is equal to, and we can factorize the right hand side, x times 3x plus 4. So we now have a quadratic which works out to be 0. So either x is equal to 0, and when x is equal to 0, we can find for y to determine the coordinates. So we substitute that into the equation y is equal to x cubed plus 2x squared minus 1. And if we substitute x is equal to 0, y is equal to 0 cubed plus 2 by 0 squared minus 1. So y is equal to minus 1. So the first stationary point will be when x is 0 and y is minus 1. For the second stationary point, 3x plus 4 is equal to 0. So 3x is equal to minus 4. As such, x is equal to minus 4/3. And if we substitute into the equation again, y is equal to x cubed plus 2x squared minus 1, which is the equation of the curve, then y is equal to minus 4/3 cubed plus 2 by minus 4/3 squared minus 1. Works out to be 5 over 27. And the second stationary point coordinates will be when x is minus 4/3 and y is equal to 5 over 27. So part 2, the nature of each stationary point. So d2y dx squared is equal to the differential of dy dx. So d dx of, and we know dy dx is 3x squared plus 4x. We worked that out in part 1. And if we differentiate that, it's going to give us 6x plus 4. So that's our second differential. One method of finding the nature of each stationary point, whether it's a maximum or minimum, would be finding the second differential. So now that we know the second differential is 6x plus 4, let's substitute when x is equal to 0 at the first stationary point. So that will give us d2y dx squared is equal to 6 by 0 plus 4. And that works out to be something which is positive or greater than 0. So that indicates it's a minimum point. And for the second stationary point, then d2y dx squared is equal to 6 by minus 4/3 plus 4. 6 by minus 4/3, 3 into 6, 2, 2 4s are 8, so again minus 8 plus 4, and that works out to be minus 4, which is less than 0. So that indicates that the second stationary point is a maximum. Part B, differentiate y is equal to 2x by the square root of 4 minus 8x. With respect to x, simplifying your answer. So we can use the product rule, so the differential of 2x by 4 minus 8x to the power half, which is the same as square root. So let's recall the product rule. D dx of uv will be u dv dx plus v du dx. And we're trying to use the same color so students can follow along. So u is equal to 2x and v is equal to 4 minus 8x to the power half. So if we substitute into the formula, it will give us 2x by d dx of 4 minus 8x to the half plus 4 minus 8x to the half, which is v, by the differential of 2x. So 2x by the differential of that is a half times minus 8 by 4 minus 8x to the power a half minus 1, which is minus a half, plus 4 minus 8x to the half by the differential of 2x, which is 2. So we can now factorize out brackets, so that will give us 4 minus 8x to the power minus a half by half of minus 8 is minus 4 times 2 is minus 8x plus 2 times 4 minus 8x. And if we expand, it will give us 4 minus 8x to the power minus a half by minus 8x plus 2 4s are 8 minus 16x. And we can now factorize out 8 as well. So we get 8 by 4 minus 8x to the power minus a half by 1 minus 3x. Because if we had worked out those brackets, it would just give us 8 minus 24x. So all we did was factorize out the 8 as well. May 2018, number 6a, show using integration that the finite area of the curve y is equal to sine x in the first quadrant, and we can bring that up, bounded by the line x is equal to 4 pi on 6, and we can bring up that line as well, And of course, we can bring up the area of that in blue is smaller than the finite region y is equal to cos x, and if you bring that up in the same quadrant and bounded by the same line. So if we consider area of sine x, that's the first one, which we have in blue there, is equal to the integral of y with respect to x between the limits 0 and 4 pi on 9. So if we integrate y, which is sine x, then that will give us minus cos x between the limits of 0 and 4 pi on 9, because this is a definite integral. So we can now substitute minus cos 4 pi on 9 minus cos 0. And of course, minus cos 0 is plus 1. So 1 minus cos 4 pi on 9 works out to be 0.83 square units. So that's the area in blue. And if we consider the area in red, the area of cos x between the same limits. So to find the area of cos x, we're integrating y with respect to x between the limits of 0 and 4 pi on 9. And we can substitute y as cos x, which we're looking at the red area. That will give us the integral of cos x as sine x, maintaining the same limits. So we can now substitute these definite integrals, which means that we don't need to write plus c, concept of integration, because it will cancel. So substitution will give us sine 4 pi on 9 minus sine 0. And of course, sine 0 is 0. So the sine 4 pi on 9 also to be 0.98 square units. And therefore, what do we realize? The area of sine x, which is what we have in blue, is less than the area of cos x, which is what we have in red. And since we have proven this by representing with a small square, or write QED, quad erat demonstrum, meaning that we have proven what was required. May 2018, number 6b. The finite region in the first quadrant bounded by the curve y is equal to x squared plus x plus 3. The x-axis and the line x equal to 4 is rotated completely about the x-axis. Determine the volume of the solid of revolution. So the volume is equal to pi times integral of y squared dx between the limits of a and b. And if we substitute for y, which is given above, it will give us pi times integral of x squared plus x plus 3 all squared between the limits of 0 and 4. The easiest way to work this out might be to expand that. So x squared plus x plus 3 all squared will give us x to the 4th plus 2x cubed plus 7x squared plus 6x plus 9 with respect to x. And for students who are getting problems working this out, we can bring up a little table there. Let's consider a big rectangle whose length is x squared plus x plus 3 and whose width is also x squared plus x plus 3. So if we subdivide that into 3 by 3 9 parts, then we can work out the area of each part. So what we're doing is multiplying that quadratic. X squared plus x plus 3 squared. So the first area will be x squared by x squared, will be x fourth. And then the second one, which we have in blue there, will be x squared plus x, which is x cubed. And then x squared by plus 3 is plus 3x squared. The next area will also be x squared by x, which is x cubed as well. And then x by x is x squared, plus 3 by x is 3x. And then the last row of rectangles, 3 by x squared is 3x squared. And then 3 by x is 3x. And 3 by 3 is plus 9. And if we're adding it, we have x to the 4th. And the two rectangles in blue will be the x cubed. So that'll give us plus 2x cubed. And then major diagonal will be plus 3x squared plus x squared plus 3x squared is plus 7x squared. The rectangles we have in brown will be plus 3x, so it's plus 6x plus 9. So the volume will be pi times the integral of what we've just written, which is x to the 5 on 5, plus 2x to the 4th on 4, plus 7x cubed on 3, plus 6x squared on 2, plus 9x, plus c, but we don't need to write the constant of integration because this is a definite integral, which means when we substitute, the c's will cancel. So volume is equal to pi times 4 to the 5th on 5 plus 2 to the 4th on 4 plus, well, 2 could go into 4, so that'll give us 2 in the denominator. So that'll be 4 to the 4th plus 7 times 4 cubed over 3 plus 6 times 4 squared over 2. And 2 could go into 6, so that'll give us 3. So 3 times 4 squared plus 9 times 4 minus 0 to the 5th on 5 plus 0 to the 4th on 2 plus 5 times 0 cubed on 3 plus 3 times 0 squared plus 9 times 0. So we substitute for the upper limit, which we have in red, as 4, and the lower limit, which we have in blue, as 0. And of course, everything in Blue works out to be 0. So we're just working out the left-hand side. So we're just working out the upper integral. So volume is equal to pi times 4 to the 5th is 1024 over 5 plus 4 to the 4th divided by 2, which would be 64 times 4 divided by 64 times 2 is 128, plus 4 cubed is 64 times 7 is 448 divided by 3, plus 4 squared is 16, 3s are 48, plus 9 4s are 36. Volume is equal to 8,492 over 15 pi cubic units. A curve has a gradient of dy dx equal to 3x minus 1, passes through the point A, 4, 1, find the equation of the curve. And this is similar to what we've done in the year before, in May 2017. So dy dx is equal to 3x minus 1. And if we want to find y, we can integrate both sides with respect to x. So the left-hand side will give us y, and the right-hand side will give us 3x squared over 2 minus x plus c. And at the point A, we know x is 4 and y is 1, so we can substitute and find for c. So 1 is equal to 3 by 4 squared all over 2 minus 4 plus c. And 4 squared is 16, 2 into 16, 8, 8 3 is 24, 24 minus 4 is 20. So we can carry that across, 1 minus 20 is minus 19 is equal to c, the constant of integration. So the equation for this particular curve is y is equal to 3x squared over 2 minus x minus 19. May 2018, number 8a. A particle moves in a straight line so that its distance, s meters after t seconds, measured from a fixed point O, is given by the function s is equal to t cubed minus 2t squared plus t minus 1. Determine part 1, its velocity when t is equal to 2. So let's bring up curve so students can get an idea of what's happening. For part 1, determine its velocity when t is equal to 2. So let's bring up that point so you can see where it is. So v is equal to ds dt, or the differential of s, and we know s. S is t cubed minus 2t squared plus t minus 1. So we can substitute. So v is equal to d dt of t cubed minus 2t squared plus t minus 1. And if we differentiate that, it will give us 3t squared minus 2 2s are 4t plus 1. And when t is equal to 2 seconds, because that's what part 1 is asking us, we can substitute. So v is equal to 3 by 2 squared minus 4 by 2 plus 1. 2 2s are 4, 3s are 12, 12 minus 8 is 4, 4 plus 1 is 5 meters per second. So at the time t, which is 2 seconds, the velocity v is 5 meters per second. Part 2. Determine the values of t when the particle is at rest. So v is equal to 3t squared minus 4t plus 1, which we've gotten from part 1. So when v is equal to 0, which means the particle is at rest, we can substitute. So 0 is equal to the quadratic 3t squared minus 4t plus 1. And we can solve for this quadratic either using the quadratic equation or factorizing. So 0 is equal to 3t minus 1 by t minus 1. Either 3t minus 1 is equal to 0, so 3t is equal to 1, as such t is equal to 1/3 seconds, or t minus 1 is equal to 0. So t is equal to 1 second. And we can bring up that point as well. Part 3. Determine the distance between the rest points. So we want to find the distance between 1/3 second and 1 second. So we know the distance that's given above is equal to t cubed minus 2t squared plus t minus 1. And we want to find it between the limits 1/3 and 1. So we can substitute. So that will give us 1 cubed minus 2 by 1 squared plus 1 minus 1. That's for the upper limit of 1. Minus 1/3 cubed minus 2 by 1/3 squared plus 1/3 minus 1, which is the lower limit. So we notice the upper and lower limits we have in different colors, so students can follow along. Works out to be minus 1 minus minus 23 on 7, which works out to be minus 1 plus 23 on 7, which is minus 27 on 7 plus 23 on 7, which is minus 4 on 27 units. So that would be the distance traveled. Last part of the question, determine the time at which the maximum velocity occurs. So at the maximum velocity, the differential of that, dv dt is equal to 0. So we can write that 0 is equal to dv dt. And we know v from part 1 and 2. So 0 is equal to d dt of the velocity 3t squared minus 4t plus 1, which works out to be 60 minus 4. So we can solve for t. So 4 is equal to 60. So t is equal to 4 over 6, which is 2/3 seconds. So the time at which the maximum velocity occurs will be 2/3 seconds, which will be in between the points of rest. May 2018, number 8b. A bus starts from rest at station A and travels a distance of 80 kilometers in 60 minutes to station B. Since the bus arrived at station B early, it remained there for 20 minutes, then started the journey to station C. The time taken to travel from station B to station C was 90 minutes, at an average speed of 80 kilometers per hour. On the grid provided, draw a distance time graph to illustrate the motion of the bus. So let's bring up the graph and let's look at the information. First of all, it started from rest, so we can indicate that at the origin, when the time was 0, the distance was 0, and that would be station A. And then it traveled a distance of 80 kilometers in 60 minutes, so you could bring up that point there, to station B. So let's draw that, let's connect the dots by drawing a red line showing from A to B, that motion. And since the bus arrived early, it remained there for 20 minutes. So the distance did not change. So it moved from 60 minutes until 80 minutes at the same distance. So we could draw a line horizontally across, which would still represent with still a station B. And then it moves to station C. The time taken to travel from station B to C was 90 minutes. So from 80 and we add 90, that'll give us 170 minutes at an average speed of 80 kilometers per hour. So we know that line is sloping upwards to the right somewhere there. So let's put a station C there for the while. And let's leave the graph there as is for the while. Let's go to part 2. Determine the distance from station B to station C. So the average speed is equal to total distance over total time taken. So the total distance will be the average speed times the total time taken. And we know the average speed, that's given as 80, times the total time taken is 90 minutes, which is 90 over 60, which is an hour and a half. So 0 cancels 0, that will work out to be 120 kilometers. So the total distance moved from station B to station C is 120 kilometers. So you can now put that on the graph. We know it went to 170 minutes. It moved 90 minutes to the right and then 120 kilometers upwards. So let's indicate that point there and let's connect it. That's from B to C. So we've completed the distance time graph. Part 3, determine the average speed from station A to B in kilometers per hour. So average speed is equal to total distance over total time, which is 80 kilometers is the distance over the total time taken is 60 minutes, which is 1 hour. So 1 into 80 is 80, so the average speed is 80 kilometers per hour. May 2019, number 5a, the stationary points on a curve are given by 5, 11 and 2/3, and 3, 15. So let's bring up a graph indicating those points. So dy dx is equal to 0. So when x is equal to 5, that indicates x minus 5. It can be used to represent that. And similarly, when x is equal to 3, you can show a dotted line there as well to indicate that that is also a stationary point. So it's showing us the gradients at those points are 0. So dy dx is equal to x minus 5 by x minus 3. And you can expand the brackets. It will give us x squared minus 8x plus 15. So that's dy dx. Now part 2, determine the nature of the stationary points. Find the double differential. So d2y dx squared will be the differential of dy dx. And we know dy dx from part 1, so we can substitute. So that will be equal to the ddx of x squared minus 8x plus 15. And if we differentiate that, it will give us 2x minus 8. So when x is equal to 5, and we substitute, d2y dx squared is 2 by 5, is 10 minus 8. 10 minus 8 is 2, which is greater than 0. So that indicates it's a minimum point. And when x is equal to 3, we can substitute. So d2y dx squared is 2 by 3 minus 8. 6 minus 8 is negative or minus 2. So that's less than 0. So that indicates a maximum point. So let's determine the equation of the curve. Since we know dy dx is equal to x squared minus 8x plus 15, we can integrate with respect to x both sides. So that will give us y is equal to x cubed over 3 minus 8x squared over 2 plus 15x plus c, the constant of integration. But if you notice here, we have 3 unknowns, y, x, and c. So let's substitute when x is equal to 3. We know y is 15 for that point. So that will give us 15 is equal to 3 cubed over 3 minus 4 by 3 squared, because 2 into 8 is 4, plus 15 by 3 plus c. 3 cubed is 27, 3 into 27, 9, minus 3 3s are 9, 4s are 36, 9 minus 36, plus 53s are 45, plus c. And 9 minus 36, 9 plus 45 is 54, 54 minus 36 is 18. So 15 minus 18 is minus 3, which is equal to c, the constant of integration. As such, y is equal to x cubed on 3 minus 4x squared plus 15x minus 3. And we can bring up that curve in green there so you can see that it hits at 315. That's the maximum point, and so forth. But there's a mistake in this question because the curve at this minimum point doesn't actually cut 5 by 11 and 2/3. And why we're showing this is because you could have worked out part 3 doing the same integration and finding y is equal to x cubed on 3 minus 8x squared on 2 plus 15x plus c. And to solve for c, we could have substituted the other coordinates, 5 and 11 and 2/3. And if we did that, 11 and 2/3 is 35 on 3 is equal to 5 cubed on 3 minus 4 by 5 squared plus 15 by 5 plus c. So 35 on 3 is equal to 125 on 3 minus 5 5s are 25 by 4 is 100 plus 15 5s are 75 plus c. So c would work out to be minus 5 in this case. So we'd get y is equal to x cubed on 3 minus 4x squared plus 15x minus 5, which should be that graph that we're bringing up here in black. So we can see that's a different graph. So clearly there was a mistake that was being made. I believe that the mistake was that it should have been stated that the stationary points on the curve was 5 and 11 2/3 and 3 13, which would give us the black line. But unfortunately that was how the question was set. So clearly there was an error in it. So if you substituted using one set of coordinates, you would have gotten one equation where the constant was minus 3, which is in green. The other coordinates, then you'd have gotten the constant of the equation as minus 5, and we've gotten that in black. May 2019, number 5b, differentiate 2x plus 3 squared, the cubic root of that, with respect to x, giving your answer in its simplest form. So let y is equal to the cubic root of 2x plus 3 squared. Let's use a substitution where u is equal to the brackets, 2x plus 3, so du dx is equal to 2. As such, y would be equal to u to the power 2/3, because 2/3 would indicate is u squared, the cubic root of that. The cubic root is represented as 1/3, so 1/3 times 2 is 2/3. And if y is equal to u to the power 2/3, then dy du is equal to 2/3 u to the power 2/3 minus 1, which is minus 1/3. And we can now work out for dy dx, which is what we wanted to find. So dy dx is equal to dy du by du dx using the chain rule. And we can substitute dy du is 2/3 u to the power minus 1/3 times du dx, which is 2. So that will give us dy dx is equal to 4/3 by, and if we substitute back for u, 2x plus 3 to the power minus 1/3. May 2019, number 6a, integrate 3 cos x plus 2 sin x. So if we integrate 3 cos x plus 2 sin x with respect to x, and of course it's an indefinite integral, which means we need to have the constant of integration in the answer, then when we integrate 3 cos x, it will give us 3 sin x. And if you're not sure, you can differentiate the answer. It should give you back the question. So if you differentiate 3 sin x, it will give us 3 cos x. So we're on the right track. And if we integrate 2 sin x, it will give us minus 2 cos x plus c. Part B, evaluate from the limits 1 to 4 2 root x over x with respect to x. So we want to integrate this definite integral, and we can simplify. Root x is x to the power half, and x in the denominator means x to the power minus 1. So a half minus 1 is minus a half, so we can rewrite it, the integral from 1 to 4 of 2 by x to the minus a half. And if we integrate that, it will give us 2x to the minus a half plus 1 is equal to a half, all over a half. So 2 over a half into 2 is 4, so 4x to the power half, or 4 root x, within the limits 1 to 4. So if we substitute, it will give us 4 by 4 to the power half minus 4 by 1 to the power half. And to the power half means a square root. So the square root of 4 is 2, 2 4s are 8, minus the square root of 1 is 1, 1 4 is 4. 8 minus 4 is 4. So the integral will be 4 square units. May 2019, number 6c, the point 24 lies on the curve whose gradient is given by dy dx equal to minus 2x plus 1. Determine part 1, the equation of the curve. So dy dx equal to minus 2x plus 1. So if we integrate both sides with respect to x, then y is equal to minus x squared on 2 times 2. The 2's cancel, so you get minus x squared plus the integral of 1 is x plus c. So we have a general equation here because we're not sure what c is, but we know it passes through the point 24. So if we substitute y is 4 and x is 2, then it'll give us c. So 4 is equal to minus 2 squared plus 2 plus c. Minus 2 squared is minus 4 plus 2 is minus 2. So we'll carry it across, so it'll be 4 plus 2 is 6. So 6 is equal to c, the constant of integration. As such, the equation of this particular curve is minus x squared plus x plus c, an inverted quadratic. So let's bring up that as a little sketch so students can follow what's happening. Part 2. Determine the area under the curve in the finite region in the first quadrant between 0 and 3 on the x-axis. So let's indicate that in blue. So what we're trying to find is that area there. So area under curve is equal to the integral of y dx between the limits 0 and 3. And we know y from part 1, so we can substitute. So area is equal to the integral from 0 to 3 of minus x squared plus x plus 6 with respect to x. And if we integrate, we're going to get minus x cubed on 3 plus x squared on 2 plus 6x plus c. But we don't need to write it because it will cancel out since it's a definite integral between the limits 0 and 3. So if we substitute for those upper and lower limits now, which we have in blue and red, the upper limit will be minus 3 cubed over 3 plus 3 squared over 2 plus 6 3's minus the lower limit, which is minus 0 cubed over 3 plus 0 squared over 2 plus 6 times 0. Everything in blue works out to be 0. So it gives us minus 27 over 3, which is minus 9 plus 9 over 2 plus 18. 18 minus 9 is 9. 9 plus 9 over 2. 9 2 is 18 and 9 27. So the area is 27 over 2 square unit. May 2019, number 8a, kinematics question. A car has stopped at a traffic light. When the light turns green, it accelerates uniformly to a speed of 28 meters per second in 15 seconds. The car continues to travel at this speed for another 35 seconds before it has to stop 10 seconds later at another traffic light. Part 1. On the grid provided, draw a speed time graph showing the information above. So let's look at the axes and let's put in the values accordingly. And what do we know? We know it started from rest and it accelerated uniformly, so there's a line sloping up to the right to a speed of 28 meters per second in 15 seconds. So we could draw that line. The car continues to travel at this speed for another 35 seconds. So we could draw a horizontal line for 35 more seconds, which will carry us to 50. And then it stops in 10 seconds. So from 50 to go down to 0 meters per second on the x-axis, when 50 plus 10 is 60 seconds. Part 2. Calculate the distance the car traveled between the two traffic lights. So that will be the area under the curve for a speed time graph will give us our distance. So the total distance is equal to the area of this trapezium, which is a half a plus b by h. That's the general formula. And a and b are the parallel sides, and h is the perpendicular distance. The upper horizontal line is 35 plus the lower horizontal line is 60 times the perpendicular distance is 28. And that works out using a calculator to be 1,330 meters. Part 3. Calculate the average speed of the car over this journey, giving your answer in kilometers per hour. So average speed is equal to total distance over total time, which is, and we want it in kilometers per hour, so it will be 1.33 kilometers over total time taken was 60 seconds, which is 1 minute, and we want it in hours, so it will be 1 over 60. So the average speed is 79.8 kilometers per hour. May 2019, number 8b, the last part of the question. A particle moves in a straight line such that t seconds after passing a fixed point O, its acceleration a in meters per second squared is given by a is equal to 12t minus 17. Given that the speed at O is 10 meters per second, determine part 1, the values of t for which the particle is stationary. So we know A, 12t minus 17, and we want to find when it is stationary, which means the velocity there. So we need to find v. So v is equal to the integral of A with respect to t. And we know A, so we can substitute v is equal to the integral of 12t minus 17 dt. And that works out to be 12t squared on 2 minus 17t plus c1, the constant of integration. So that gives us v is equal to 6t squared minus 17t plus c1. And we know at O, when time is 0, the velocity is 10 meters per second, so we can substitute for that. So 10 is equal to 6 by 0 squared minus 17 by 0 plus c1. So that works out to be 10 is equal to c1, the constant of integration. Therefore, the velocity equation is equal to 6t squared minus 17t plus 10. And part 1 is asking us to find out the values of t for which the particle is stationary. So since v is equal to 6t squared minus 17t plus 10, when it's stationary, v is equal to 0. So 0 is equal to 6t squared minus 17t plus 10. And this is a typical quadratic, so we can either factorize or use the quadratic formula. So let's use the quadratic formula here. So t is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, the normal quadratic formula. And we can substitute. And what is b? Minus 17 plus or minus the square root of minus 17 squared minus 4 by 6 by 10, a and c values, all over 2 times 6. So t is equal to minus 17, which is 17, plus or minus 17 squared is 289, minus 4 6 is 24, by 10 is 240, all over 12. So 289 minus 240 is 49, so we square root of 49 is 7, so we can write that t is equal to 17 plus or minus 7 all over 12. So either t is equal to 17 plus 7, which is 24 over 12, which is 2 seconds, or t is equal to 17 minus 7, which is 10 over 12, which is 5/6 seconds. So those are the two values at which the particle is stationary, when the time is 2 seconds and when the time is 5/6 of a second. Part 2, determine the distance particle travels in the 4th second. So in the 4th second, we actually want to find the distance between the time is 3 and 4. So s is equal to the integral of v dt between 3 and 4. S is equal to the integral of 6t squared minus 17t plus 10 dt between those limits. So when we integrate, it'll give us 6 on 3 t cubed minus 17 on 2 t squared plus 10t between the limits 3 and 4. And we can substitute accordingly in this definite integral. So it'll give us 3 into 6 is 2, so 2 by 4 cubed minus 17 over 2 by 4 squared plus 10 by 4 minus 2 by 3 cubed minus 17 on 2 by 3 squared plus 10 by 3. So that'll work out to be 32 minus 15 on 2, which works out to be 49 over 2 or 24.5 meters. And that is the distance traveled in the 4th second. So what we did there was find the distance at the end of 3 seconds and the distance at the end of 4 seconds, and we subtracted them. May 2021, number 4a, part 1. Differentiate sin x plus cos 4x with respect to x. Let's write that, ddx of sin x plus cos 4x. When we're differentiating this, we need to differentiate sin x plus the differential of cos 4x. And that will give us cos x minus 4 sin 4x. Part 2. Differentiate 2x cubed plus 2 all over 2x plus 1 with respect to x. So we can consider this to be a quotient rule to apply here. So let's say y is equal to u over v. And the quotient rule says that if we differentiate y with respect to x, where u and v are functions of x, that will give us v du dx minus u dv dx all over v squared. And u will be the numerator, which is 2x cubed plus 2, which means that du dx, the differential of u, is 6x squared. And the denominator v is equal to 2x plus 1. So the differential of that, dv dx, is equal to 2. So now we can substitute. dy dx is equal to v du dx, which is 2x plus 1 by du dx is 6x squared, minus u dv dx, which is 2x cubed plus 2, by dv dx, which is 2. Notice we have the colors u in red and v in green for students to be able to follow easily, all over v squared, which is 2x plus 1 all squared. And now we can expand the numerator, so that will give us 6 by 2 is 12x cubed, plus 6 by 1 is 6x squared, minus 2 by 2 is 4x cubed, minus 2 by 2 is 4, all over 2x plus 1 squared. And we can simplify, so that will give us dy dx is equal to 12 minus 4, 8x cubed, plus 6x squared minus 4, all over 2x plus 1 squared. Part B. Use the principles of differentiation to compute the stationary value of the function y is equal to x squared minus 4x plus 2. So if we're looking for the stationary value, then we want to find the differential dy dx. So dy dx is equal to 2x minus 4. And for stationary value, dy dx is equal to 0. So you can substitute for that. 0 is equal to 2x minus 4, which implies that 2x is equal to 4, so x is equal to 2. And notice something, that the equation we're dealing with is a quadratic. And if we consider a quadratic being a U-shaped graph or inverted U, then there's only one stationary point. And as this case here, our calculations indicate that there's only one stationary point where x is equal to 2. And since we want to find the coordinates, then we need to find the y value. So let's write the equation y is equal to x squared minus 4x plus 2 and substitute x is equal to 2 into there. So it will give us y is equal to 2 squared minus 4 by 2 plus 2. 2 2s are 4, minus 4 2s are 8. 4 minus 8 is minus 4, plus 2 is minus 2. So y is equal to minus 2. As such, the coordinates of the stationary point for this quadratic curve is 2 minus 2. May 2021, number 4C. This is the kinematics part of the question. A motorist starts from point X and travels 60 meters due north to a point Y at a constant speed of 4 meters per second. He stays at Y for 25 seconds and then travels at a constant speed of 10 meters per second for 100 meters due south to a point Z. Calculate, part 1, the average speed of the whole journey. So let's bring up a little sketch so students can follow what's happening. And the sketch will be an ST graph, a displacement versus time graph. And what do we know? It starts at X, where we consider the distance to be 0 and the time 0. And it heads due north to a point Y for 60 meters at 4 meters per second. So 4 into 60 is 15, so it takes 15 seconds for that to happen. We can draw a green line indicating the movement from X to Y. It now stays at Y for 25 seconds. So from 15 seconds, let's add 25 to that, so that'll give us 40. So we can draw a horizontal green line to indicate that we're still at Y at the time of 40 seconds. And then the motorist travels at a constant speed of 10 meters per second for 100 meters due south. So he's going in the opposite direction. If he started at 60 and he moves 100 meters in the opposite direction, he'll end up at minus 40. And since he's moving 10 meters per second, 100 divided by 10 is 10 seconds. So it takes him 10 seconds to do such. So from 40 seconds, it went to 50 seconds. So we can find the spot where Z is. So let's draw the line to show from Y to Z. Calculate, part 1, the average speed of the whole journey. So average speed is equal to total distance traveled over total time taken. So average speed is equal to 60 from X to Y. And then during the second phase where it was flat, the distance traveled was 0. And through the final phase from Y to Z, he traveled another 100 meters. So 60 plus 0 plus 100 all over 15 plus 25 plus 10, which gives us 160 over 50, which works out to be an average speed of 3.2 meters per second. Part 2, calculate the average velocity of the whole journey. So average velocity is equal to total displacement over total time taken. And the average velocity will be, if we're looking at displacement, it was 60 minus 100 all over 15 plus 25 plus 10. We must count the piece where he was at rest, because all that is part of his total time taken. So we're getting minus 40 divided by 50, which means that his average velocity is minus 0.8 meters per second. So if he started at X and moved at a velocity of 0.8 meters per second in a southerly direction, after 50 seconds, he would end up at Z. May 2021, number 5A. Determine the following integrals, giving each answer in its simplest form. Part 1, the integral of 2x squared plus 3x with respect to x. So this is an indefinite integral. As such, our answer will include C, the constant of integration. So if we integrate 2x squared, it will give us 2x to the 2 plus 1, which is 2x cubed over 3. So we can write that as 2/3 x cubed plus 3x squared over 2 plus C. And for part 2, integrate 2 sine 3x dx. And if we recall that the integral of sine ax dx is equal to minus 1 on a cos ax plus c, then if we apply such, it will be equal to minus 2/3 cos 3x plus c. Part B, using an integration method, calculate the area of the region in the first quadrant under the graph y is equal to 3 sine x. So let's bring up that graph. And of course, it looks like the graph y is equal to sine x, where it cuts at 0 and pi, but it's 3 times that amount, meaning the y values will be 3 times the amount. So the maximum point will not be 1, like a normal sine graph, it will be 3 times 1, which is 3. And since we want to integrate it within the first quadrant, it means, as we look at the graph, it's at the points between 0, 0, the origin, and the point pi 0, which are the two roots of the graph. So let's integrate 3 sine x dx between 0 and pi. So we want to find that blue area, of course, and that will be equal to 3 minus, what's the integral of sine x, minus cos x, between the limits 0 and pi. And we have them in different colors, the lower and upper limits, so students can easily follow. And now what do? We say 3 times, and we substitute minus cos pi minus cos 0. So that works out to be 3 by minus, and what's cos pi? Minus 1 minus cos 0, and cos 0 is 1. 3 by minus 1 is 1, minus 1 is 1. So 1, 1, 2, 3 2s are 6. So the area of the region is 6 square units. May 2021, number 5C. The kinematics part of the question in integral section. A particle starting from rest travels in a straight line with an acceleration a, given by a is equal to t squared, where t is the time in seconds. Part 1. Determine the velocity v of the particle in terms of time t. So we know v is equal to the integral of a dt, a formula which is given in the formula sheet. And since a is given above as t squared, we can substitute. So v is equal to the integral of t squared dt, which will be the integral of t squared is 1/3 t cubed plus c1, the constant of integration. And at this point in time, this equation has 3 unknowns, v, t, and c1. And we should be able to find for c1 the constant of integration because we know the particle is starting from rest. So when time is 0, the velocity is 0. So if we substitute for v and t as being 0, then that's going to give us 0 is equal to 1/3 by 0 cubed plus c1. So c1 is equal to 0. As such, the formula for velocity is v is equal to 1/3 t cubed units per second. Part 2. Calculate the displacement s of the particle in the interval of time t is equal to 0 to t is equal to 2. S is equal to the integral of v with respect to t between that time interval of 0 and 2. So this is a definite integral, and we know the upper and lower limits. And we know v from part 1, so we can substitute s is equal to 1/3 t cubed, the integral of that, between the limits 0 and 2. And when we integrate that, it will be 1/3 t4 times divided by 4. So it will give us 1/3 t cubed divided by 4, which is 3/4 are 12. So 1/12 t4 between the limits of 0 and 2. And of course, we have the upper and lower limits in different colors, so students can follow easily. And if you want to find s now, we can substitute. So it'll be 1/12 by 2 to the 4th minus 1/12 by 0 to the 4th. And of course, 0 to the 4th is 0. So we're only looking at 2 to the 4th divided by 12. 2 to the 4th, 2 2s are 4, 2s are 8, 2s are 16 over 12. We can break that down, so that will give us 4/3 units, which is the displacement in the first 2 seconds of motion. May 2022, number 4a. Given that f of x is equal to x by 5 minus x squared, determine f double bar x, means the double differential. So since we know f of x, let's rewrite f of x. And we can expand the square, so that will give us x by 25 minus 10x plus x squared. And we can now multiply through it by x, so that will give us 25x minus 10x squared plus x cubed. And if you want to find f bar x, or the differential of f of x, that will be 25 minus 2 tenths are 20x plus 3x squared. And we want the double differential f double bar x, so that will be equal to minus 20 plus 3 twos are 6x. B. Differentiate each of the following expressions with respect to x, simplifying your answer where possible. Part 1. 2 sine 3x plus cos x. So let f of x equal to 2 sine 3x plus cos x, and we want to find f bar x. So when we differentiate that, we'll get 2 times 3 cos 3x minus sine x. So f bar x is equal to 6 cos 3x minus sine x. And we want to differentiate part 2 as well, 1 plus 2x cubed by x plus 2. Let g of x is equal to 1 plus 2x cubed by x plus 2, and we can now look at that as a product. So we can use the product rule in order to solve this differential. So let's recall that d dx of uv is equal to u dv dx plus v du dx. Notice we have the colors u in red and v in green for students to easily follow what's happening. So where u will be 1 plus 2x cubed, which means that du dx would be 3 times the coefficient of x, which is 2 times 1 plus 2x to the power 2. And v is equal to x plus 2. So dv dx is equal to 1. So g of x is equal to 1 plus 2x cubed by x plus 2. So g bar x will be following that formula, u dv dx plus v du dx. And if we substitute, it will give us 1 plus 2x cubed by 1 plus x plus 2, because that's v, by 3 by 2 by 1 plus 2x squared. So work it out, it will give us 1 plus 2x cubed plus 3 twos are 6 by x plus 2 by 1 plus 2x squared. 1 plus 2x cubed can be written as 1 plus 2x by 1 plus 2x squared, plus 6 times x is 6x, plus 6 times 2 is 12 by 1 plus 2x squared. So we can now factorize out the 1 plus 2x squared. So we're left with 1 plus 2x plus 6x plus 12. So g bar x is equal to 1 plus 2x squared by 2 plus 6 is 8x plus 13. May 2022, number 4c, part 1. Determine the stationary points on the curve y is equal to x cubed minus 4x squared plus 4x. And we know if it's a cubic graph, it will more than likely start at one infinity, go up, come down, and go up to the other infinity. Let f of x is equal to x cubed minus 4x squared plus 4x. So f bar x, which is the differential, will be 3x squared minus 8x plus 4. And at the stationary points, it means that f bar x or dy dx is equal to 0. It's interchangeable whether we write dy dx or we write f bar x. Both means the differential of x. So if we substitute now 0 is equal to 3x squared minus 8x plus 4, we have a quadratic equation equal to 0. So how do we solve? Either use the quadratic formula or we factorize. So I'll factorize here. So 0 is equal to x minus 2 by 3x minus 2. Either the first bracket's x minus 2 is equal to 0, which implies x is equal to 2. And if we want to find the coordinates, when x is equal to 2, we can find the y coordinates by substituting. Let's write the formula f of x equal to x cubed minus 4x squared plus 4x. And if we substitute f of 2, it will give us 2 cubed minus 4 by 2 squared plus 4 by 2. 2 cubed is 8 minus 4 by 2 twos are 4 minus 16. 8 minus 16 is minus 8 plus 4 twos are 8, which is 0. So f of 2 is 0. So that means the coordinates of one of the stationary points is x is 2 and y is 0. And for the other stationary point, let's look at the other brackets. So all 3x minus 2 is equal to 0, so 3x is equal to 2. As such, x is equal to 2/3. So that will be a second stationary point. And when x is equal to 2/3, let's substitute into f of x. So we get f of 2/3 is equal to 2/3 cubed minus 4 by 2/3 squared plus 4 by 2/3. 2/3 cubed will be 8 over 27 minus 4 by 2/3 squared, which is 16 over 9 plus 4 by 2/3 is 8 over 3. And we can use our calculators and f of 2/3 works out to be 32 over 27. So for the second stationary point, the x value is 2/3 and the y value is 32 over 27. Part 2. Providing details determining the nature of each stationary point in C Part 1. So if we know f bar x from Part 1, then we can work out f double bar x. And if we differentiate that, it will give us 6x minus 8. And let's substitute f double bar x, the two values of x, to find the nature of the stationary points. So if we say f double bar 2, because x is 2, that will give us 6 by 2, which is 12 minus 8. 12 minus 8 is 4, which is greater than 0. That implies that it is a minimum point at x equal to 2. And at f double bar 2/3 will be 6 by 2/3 minus 8. 6 by 2/3, 3 into 6, 2, 2 2s are 4, 4 minus 8 is minus 4, which is less than 0. And since it's less than 0, this means that this is a maximum point at x is equal to 2/3. So we can complete the graph by showing the cubic equation here. May 2022, number 5a. Determine the integral of 4 cos theta minus 6 sin theta d theta. And if you integrate 4 cos theta, it's going to give us 4 sin theta. And if you integrate minus 6 sin theta, it will give us plus 6 cos theta. Plus c. Don't forget the concept of integration because this is an indefinite integral. And for b, determine the integral of 3 minus x all squared between the limits of 1 and 2. What we're really saying is we have a quadratic graph which is touching the x-axis at one point where x is equal to 3. So we can bring up that graph. We want to find the area under the graph where the lower limit is 1, so we can bring up that. And the upper limit is 2. We'll indicate that with a blue area there to show what we're trying to find. So how do we integrate 3 minus x squared? There are a couple of ways to do it. One of the easier ways will be just to expand the brackets. So 3 minus x by 3 minus x will give us 9 minus 6x plus x squared. And we're integrating that, of course, between the limits. So it'll give us 9x minus 6x squared over 2. 2 into 6 is 3, so 3x squared plus 1/3 x cubed between the limits of 1 and 2. So we now substitute the upper and lower limits. So that'll give us 9 by 2 minus 3 by 2 squared plus 1/3 by 2 cubed minus 9 by 1 minus 3 by 1 squared plus 1/3 by 1 cubed. So 9 2s are 18 minus 3 by 2 by 2, which is 12. 18 minus 12 is 6. 6 plus 2 cubed is 8 over 3. So 6 3s are 18. 18 and 8 is 26 over 3. Minus 9 1s are 9. Minus 3 by 1 is 3. 9 minus 3 is 6. Plus 1/3. 6 3s are 18 and 1 is 19 over 3. So 26 over 3 minus 19 over 3 is 7 over 3 square units. That will be the blue area indicated. Part C. Determine the area of the region bounded by the curve y is equal to 5 plus 5x minus x squared. And that is an inverted quadratic, so you can bring that up for students to get a general idea of what the sketch looks like. And we're finding the area under the graph between that curve and the x-axis, the y-axis, and the line x is equal to 2. So how do we do that? In order to find the area, that will be the integral of y dx between those limits. So let's substitute for y. So it will be the integral from 0 to 2 of 5 plus 5x minus x squared with respect to x. If we integrate that, it will give us 5x plus 5 on 2 x squared minus 1/3 x cubed between the limits. So let's substitute for the upper and lower limits, which we have in red and blue for students to follow. So that will be 5 by 2 plus 5 on 2 by 2 squared minus 1/3 by 2 cubed minus 5 by 0 plus 5 on 2 by 0 squared by 1 minus 1/3 by 0 cubed. So 5 2s are 10 plus 2 2s are 4, 2 into 4, 2, 2 5s are 10, so 10 and 10, 20, minus 2 cubed is 8 over 3. 23 is 60, 60 minus 8 is 52 over 3, minus, and the lower limit works out to be 0. As such, that area, which you have indicated in blue there, works out to be 52 over 3, or 17 and 1/3 square units. May 2022, number 5D, kinematics part of the integral question. A particle moves in a straight line so that t seconds after passing through a fixed point O, its acceleration a is given by a is equal to 3t minus 1 meters per second squared. When t is equal to 2, the particle has a velocity v of 4 meters per second and a displacement of 6 meters from O. So they're giving us some values to work with. Determine the velocity when t is equal to 4. So how do we find velocity? From the formula given, velocity is equal to the integral of a dt. And we know a is given above. So we can substitute v is equal to the integral of 3t minus 1 dt, which is v is equal to 3 on 2 t squared minus t plus c1, constant of integration. And what do we know? We know when the velocity is 4, the time is 2. So we can substitute accordingly. So 4 is equal to 3 on 2 by 2 squared minus 2 plus c1. 2 squared is 4, 2 into 4, 2, 2 3 is 6, 6 minus 2 is 4. So 4 is equal to 6 minus 2 plus c1. 6 minus 2 is 4, we carry it across, 4 minus 4 is 0. So 0 is equal to c1, as such the velocity is equal to 3 on 2 t squared minus t. And we want to determine the velocity when t is equal to 4. So velocity is equal to 3 on 2 t squared minus t, so we get a substitute when t is equal to 4. So v is equal to 3 on 2 by 4 squared minus 4. 4 squared is 16, 2 into 16 is 8, 8 3 is 24. So v is equal to 24 minus 4. So v is equal to 20 meters per second. We've now come to the end of CSEC past paper questions in the subject of additional mathematics, specifically in section 3, Introductory Calculus and Kinematics. In our last two videos, based on 2012 to 2016, we did the 5-year solutions on Introductory Calculus, and then we did a second video on the 5-year solutions in Kinematics. And this video shows us from 2017 until 2022, the combination of both topics, Introductory Calculus and Kinematics. Don't forget to look at the description down below. So we've outlined the general format. We suggest that you go through the playlist in order for you to cover the entire syllabus, for you to get a better grasp.